Now I'm ready to start. Yep, hello again, session 5. Welcome, welcome, welcome. Thank you. Trying to be what? Beedle? Yeah, Beedle. That one. Beedle in Skyward Sword, he's just run out of stuff that I can buy. He ran out of stuff that I could buy like 3 dungeons ago. I'm really not pleased. Usually he sells good shit. He doesn't anymore. I think it's just too easy to make money in Skyward Swords, to be honest. That's probably what the problem is. Yeah, but what you gonna do? Cool. Well, if I recall correctly, I'm not IRL anymore. I switched it back to programming. Looking through my analytics, IRL, I had like 12 unique hits, but nobody stuck around. Whereas with the programming section, people tend to stay just a little bit longer, which is kind of understandable, the distinction. You know, IRL makes you more popular, but does it really? For how long? Does anyone actually stick around? Doesn't really make much of a difference. But what I have done is I've reappropriated the little text, like just below, in order to just be able to write what I'm doing, so that anyone tuning in can immediately spot that. So yeah, I mean, it follows on from the previous session where I did task 2A, which is this one. You know, I tried to do it to the best of my ability, and literally, when I finished my 7-part recipe for it, which I wrote down here. You can see all the 7 parts that I did. Finished that, and so it's just time to test, literally, nothing else. You know, this is the full recipe that you can see on the screen now, if this would just piss off. Cool. Yeah. You know, I reasoned through it very slowly, tried to make sure I got it right, conceptually as much as possible. But of course, the test absolutely doesn't work, as per. So I'll just do my quick initialization and show you guys what the test is saying. Go test, run to pick out the tests applicable to task 2A. Yeah, pretty basic shit. It just says, you know, trying to elect a leader. After 5 seconds, it'll just say like, oh, failed to elect leader. Expected 1 leader, got none. You know, what I want to know, because I have implemented all this shit, what I would really like to know is how it knows that there's no leader. How does it test for a leader? That would be my entry point into debugging, would be to know if there is or is not a leader. Yeah, I just wanted to say, by the way, about yesterday, 4.5 hour stream. This shit is hard. Like, I'm finding it a lot harder than I thought it would. I'm not sure if Max and Ben really did do it in 2 sessions, like 4 hours, the whole of the Raft. Did that happen, or did they not finish? I don't know. But to me it seems so much harder than MapReduce. So much harder. And yeah, I'm kind of teetering on getting burnt out going for streaming sessions that are that long and then keeping it up next day, immediately back on it, trying to get shit to work. I'm not sure I'm going to make it, you know, it's already the 11th. I only have really 3 days to work with. I'm not sure I'm going to make it by my deadline of the 14th. Probably not, unfortunately. But yeah, I'm going to persevere. Next session, I'm not sure when it's going to be. I've said I'd like to try doing it this time tomorrow, or rather 2 hours earlier. That sleep. Staying up watching Wind Waker HD speedruns. Shout out to Linkus. But I mean, yeah, I'm just gonna, I don't know, try my hardest for a little longer. If I get through to A in one piece, might continue, otherwise go for a little break and try to reorganize my schedule, because it's 14th to 17th inclusive. I'm so busy with going out, events and things, and like one job related thing, one meetup with somebody, one Pokemon Go community day, and one concert / meetup with somebody unrelated to the previous somebody. Well, it's like 2 separate groups. Yeah, pretty much. I mean, I was kind of happy about how I managed to concentrate so well in the previous session, so I just, kept drilling it one after the other. So when I get into it, I can really push forward. Although, it makes for a slightly less entertaining stream because I'm concentrating on working too hard, or work and no play. But that's completely cool. If you get fixated on something, you get the determination, the drive to see it through, and I kind of did. It's just everything needs to be tested and repaired. So yeah, I'm down with that. Ready to start? Ready or not? Boom, 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 boom. That was supposed to be from Flying Lotuses You're Dead, but never mind. I've probably completely forgotten that song. Yeah, so I mean, without further ado, let's begin the debug. I've already shown you guys this initial state. This is the position we're currently in. Whoops, I just want this to stick to editor. So yeah, I've shown you that, and so I want to figure out what's going on, do a debug. So much debugging that has to be done in any software related job, role, study, coursework, whatever. Hardcore. You see this, expected 1 leader, got none. Len leaders, how is it figuring out who the leaders are? That's what I would like to know. We make a map. Okay. That's what's going on. So in order to find out leader, it is using the getState function that we defined that accesses a variable, Raft instance's state, or indeed phase variable. I'm calling it phase. I might rename it to state, but I like the word phase. Leader phase, follower phase, candidate phase. So it's using that in order to figure out if something is leader or not, right? It's saying if term leader equals this shit, comma leader, boolean, leaders at term we append I, which is every I here represents a single peer. So the question is which part of this is what's failing, when it's just telling me expected 1 leader got none. Should we try to get more verbose output by setting debug on? I'm not sure if that will actually do verbose at all. I'm just going to give it a quick shot just in case it works. So I'm just trying to, at this phase, get a bit more information about the test itself, why it's not working. But yeah, unfortunately I'm not getting any information. I'm going to use dprintf in order to print. I have absolutely no problem doing that. And I know that I can, if I want to, save output to out by running this, collect output in a file, insert the print statements, and then collect output to a file. That's something that we can do in order to debug. It says here, insert print statements whenever a peer sends or receives a message, so an RPC, and collect the output in a file with go test run 2a out. So shall we do that first as our first step to debugging? So I'm using dprintf, which is defined here as literally just something that prints. It's the standard sort of print learn or whatever. Printf, yeah. It's the standard thing in that sense, but it gets enabled and disabled depending on whether or not debug is set to 1 or 0, or something non-zero and 0. So I'm happy to use dprintf as my print statement thing. Basically, that's where it's coming from. So this auxiliary file here contains a kind of debug-enabled print, one of those things. So if I set this to 0, even if I don't delete the dprintfs, they will not come up, and so I can clean them up later. It's kind of, I guess, a nicer way of debugging. So yeah, what we want to know is whether or not things are leaders and or followers, what things are send message, get states. I don't know. Let me first jump back into config.go, the test routines. Just to, again, be a bit clearer on how it figures out who the leader is. So it's saying if term leader, first it calculates term and leader, and then it says if leader is true, it appends a leader. And it says got none here, so we're fine. What we're aiming for is to have at least one leader at this stage. That's the obstacle we're at now. We're getting 0 leaders. And it's saying, it needs to be cfg.connected and leader needs to be set to true. So I know what this is in terms of the code. It's just get state, the phase that I've defined needs to be leader. That's how it's testing whether or not something is leader. But it's also saying we should have cfg connected whether each server is on the net. But I think that's something that's automatically true because there are not failures in the initial election test. This is just an election, and this is an election after a network failure. So in the initial election, I don't think anything fails at all. And so, yeah, something should be the leader, nothing is the leader, so let's find out why. Jump in, raft.go. Fairly complicated code already. What we can do is insert some statements on the phase changes. I know it says insert statements on the RPCs, but I would rather start by inserting print statements on phase changes, okay? So that's what I'm going to do. I'm going to print rf.me followed by rf.phase. Problem? rf.me has to be cast. I mean, what? Why? Why not just be less stupid and use like print learn without a fucking interface, which is just... is this gonna do what I want it to? I can't print learn stuff with commas. Oh yeah, I remember trying to implement that in JavaScript. It gave me all sorts of trouble. Okay, let me just dprintf individual things then. So can I dprintf rf.me? Does that throw a syntax error? Well, no. Again, it's saying, is this still messed up? Control Z. I want all the changes undone, for fuck's sake. Oh no, this is all fine. Sorry. I do not want to save the changes to util.go. Okay, I want it to stay like that, and I do not know why this is taking the piss. Just fucking revert this file, please. Bloody what? Okay, cool. And now I'm just going to set debug to 1 again. Yeah, so yeah, this just does not work. I would have to cast everything to string, everything that I wanted to print. So yeah, thanks MIT for being useless. That's just going to waste my time. Instead, I'm going to use standard fmt.printlns. Hey, can I make an alias for println somewhere that I can use for debugging? I think I can do that. So I'm going to define a function that just runs println. Yeah, that's how you would make an alias. And I'm going to put it somewhere. Oh, I'll put it all the way at the top so that I don't miss it. Somewhere up here. Import fmt is the package that we need in order to print anything at all. And then I'm just going to func. Yeah, just to remind myself of the notation. What should I call it? The test printer. I'm just going to call it the capital P, just to make it as easy as is possible. An alias for println called P. Oh, I don't want a function declaration, do I? I'm going to write it like this: var P equals fmt.println. Okay, so hopefully this works as an alias. Exported var P should have comment or be unexported. Yeah, I do want it to be capitalized, so I'm gonna do the usual syntax thing. Okay, so now if I use P, it should work, hopefully, as a kind of debug tool that I can then just delete. So let's see if it works. First I'm going to put in a print statement in the make, the initialization thing. Make. Just to test that printing is indeed working. Okay? So we're going to be running tons of tests today. It's just going to be the same old tests. The test is going to be test initial election 2A. Which I can, if I want, specify as so it's initial election and then re-election. Yeah, I can't specify that. I can't distinguish the two tests easily, so I'm going to run them both each time. Yep, so the printing is working. It's run yeah 3 times. Why has make been run 3 times? Is there a reason for that? Seems a bit weird to run make 3 times. Oh yeah, no, sorry, it's running make 3 times because I think there are 3 pairs. Okay, cool. That's fine. So yeah, I can debug just by using the letter P. That's the point. So that's how I'm printing to the log here. P is an alias for fmt println, which is my usual print statement. Okay, let's go. Let's go, boys. Let's go. Let's go, girls. Yeah. So I don't know why I've started using that phrase. I don't usually use it. It's unnecessarily gendered, isn't it? Okay. So yeah, let's do some print statements at each initialization. So first of all, let's see if init follower does a print statement. Yeah, as in, let's do a print here when a follower becomes a follower, basically. And actually, yeah, I'm just going to go ahead and put in this print statement for absolutely every situation. So I'm printing, yeah, it takes interface type. Fly is back. So I'm going to print me, followed by my phase. Okay? So this print statement here is going to be put into all of the initializators. So init leader, thinking, you know, it's just to clear the code up, I would like fly fucked off. Just to clear the code up, I might put all of this because it's in a quick function that I pass in the phase that I want something to become, and it's like a set phase function, and it looks like this. Then I can have the only one print statement as well. But you know, I'll consider doing that. It's not really easy for the candidate to do that because it would have to lock twice, and that makes the code less inefficient. Less efficient. Less inefficient would be the one. Alright, go test run 2A. Here we go. So, everything is becoming a follower once, and then it's failing. All the peers become followers once, and then they fail to time out properly. So that's what the problem is. So why is that happening? Let's find out. Init follower runs this piece of code in its own loop. So time after seems to not really be firing correctly. You know, I'm using election randomization, election timeout, that many milliseconds as a time after to fire this thing. So I'm going to print within the follower code. Okay, I'm going to make the debug code. I'm not going to worry about locks too much on the debug code. I'm just going to put these in, YOLO it a bit. So yeah, print myself followed by reset. Whereas here I print myself followed by timeout. Okay, so let's see what happens. Deary me, neither of these cases is firing. So election reset should not be firing necessarily. Well, actually, I mean, it should be the way I implemented it. Heartbeats should be happening. But yeah, I'm more concerned about the fact that time after is not firing. So I think I've done something wrong here. Time after should definitely be firing. Or maybe I should hit the, you know, let me print select. What's happened? Yeah, I can't print there. I have to print before the select. Yeah, they all hit the select and then get jammed because time after seems to not be working. What is the problem with time after? Time after should be fine. I tested that in a tour of Go, if you remember, so I don't see why it's being a problematic now. Let's print the let's print this number. Let's print I'm gonna try to print the entire argument of time after, okay? Which should be a duration. I'm gonna try to print the whole damn thing. So the fact that I'm printing this means that the number's not going to be the same as this one, but the point is I'm just trying to see if it loosely works. Right, that's all I'm trying to do at the moment, because it's getting stuck here for reasons that are unknown. What the fuck, 138 hours, 53 minutes, 20 seconds. That's clearly too long. 138-hour leadership timeout. The fuck, mate. Yeah, I fucked something up in the constants. Okay, so that's where the problem is. What has happened here? Election randomization. It's just evaluating to completely the wrong thing. So election timeout is 500 milliseconds. Election randomization is 150. This is just an integer, or it's a non-typed constant for the time being. But yeah, a heartbeat timeout is irrelevant. So election timeout and election randomization. Hello. So we use election randomization to get a random number, convert that to a duration. Oh, okay, yeah, this is converting to a duration. Don't forget, this is a random number. Election timeout is 500. Election randomization is a random number from 0 to 150. It seems to be giving me loosely the same number, which is interesting here. But yeah, I'm adding 500 milliseconds to this, which is the my code here is a bit monged, to be honest. I'm not reasoning through it correctly. Okay, so I know what the variables are and what types they have. Can I just like? Well, no. Election randomization has to be integer type because it's going straight into the random number generator. Which means this is a random number. I need to immediately convert that into a duration. I need a bit of help doing that, to be honest. The problem is that you can't just convert type because it's a number, and there's no information about how you should interpret a number as a period of time. So the unit is missing. The unit should be milliseconds, but I don't know where exactly I should specify that. So let's see if we can find out. Golang convert int to duration. How is this supposed to be done? Yeah, the duration I want is time millisecond, and I want to multiply that to an integer. So if you do time duration, does that automatically convert to seconds? So then I multiply it to time milliseconds to get to the correct format. Yeah, I think that's correct. I think the number is. I think I don't know what format it's in, but the time duration should straight off the bat be turned into milliseconds. So I'm saying time duration. This is 3 parens 4. Okay, -2 -1 0. And then I add election timeout, which is already in the correct format. Namely, it's in milliseconds. I think this works. Surely there is a spot here where I can just perfectly legitimately define timeout. And this variable, just to make the code clearer, can go there. Yeah, so it is possible for me to just do that because every time every time the for loop comes round, select is only run once, and so we can decide what the timeout should be at that point, basically. So yeah, this code is, I mean, I'm just saying this code is fine, right? Decide on what the timeout is here, print the timeout so that we're getting the right numbers, we can check that, and then run the select case using timeouts, okay? That should be completely fine. Let's find out if it works. It is exciting always testing. Yeah, see, it's working now. It still failed for some reason, but like, yeah, the timeouts are actually triggering correctly. So you can see the timeouts being written here. You know, everything is a follower. Then it, you know, this much. This is the length of time that is the timeout, the election timeout. Like, it's intended to be a random number between 500 and 650, which is what these are. Alright, then 1 times out and becomes a candidate. 2 times out and becomes a candidate. And 0 times out and becomes a candidate, and then they lock and fail to proceed. Okay. So this seems to be working. So I'm gonna delete those print statements. No, I'll still go ahead and leave the timeouts and resets in. I think those are useful. But at least we know that the timeout is getting correctly decided there. Okay, so then all of them become candidates, and then what? So what should be happening when each one becomes a candidate? There is definitely a lock happening, and so the code is going to run one candidacy at a time after it sends all of the RPCs out to request votes. So in send request votes, I'm going to put in a print statement to see if that is working correctly. So yeah, send request votes. Print statement goes in. The print statement is going to be rf.me sends request votes to what's the simplest way of writing this in a nice, clean, easy to read manner? I'm going to do it this way. Request votes rf.me to whoever the hell is being requested from, which is a server. In principle, rf.me is just in the args. So I can, if I want, literally just go args dot candidate ID to make the code less lockable and also test that that's working as well. So send request vote is now covered by print statements. So yeah, this is working as intended as well. These are timing out, but they're not allowed to do anything because of the lock until all the request votes have been sent, which is chill. And it's sending them to the correct places. As you can see, it's not asking for a vote from itself. So, okay, now we need the print statement in the reply. Right, this is the reply handler. Print statement, request, vote. And it's going to be a reply. So how should I phrase that? Well, the sender is candidate ID in args. The receiver is server, and it's going in. The message is going in the opposite direction. The receiver is myself, rf.me here. But is the receiver specified anywhere? I think it is in args dots. No, because the RPC call, it goes into, receiver goes into, don't forget it's server args, like destination args and reply, and so destination does not get saved anywhere, so I have to access it using rf.me, I think, the introspection. Okay, cool. So yeah, messages are going to and from shits. You can see initial election. Let's just read this. You know, this sensor sent and immediately received a response. It seems to be more or less sending and receiving. As you say, sorry, as I said earlier, the sends have to happen before the timeout because of the lock, but the receives can happen afterwards, as has happened here. That's completely okay. Pretty sure that's not a problem. So I'm also gonna add to the statements here, the print statement. I'm gonna add what was replied. Vote granted. Yeah, vote granted is the payload really, the bit that we care about. So I'm gonna get vote granted to also be printed. So that's cool. This all happens, the entire request vote handler happens within the lock. I think that is necessary because voted for has to be set as well as the whole handshake setting the terms. That's totally cool. Okay, go test run 2A. I'm going to control C just to make things less messy. Yep. So what's going on? A few more print statements. You know, sends come out, receipts come out as well. So look, both of these have correctly voted true. And then the other thing calls a vote in the same term, and you can see 1 has not voted yet, so it votes for 2. In this case, 2 and 0 had not voted yet, so they vote for 1 because 1 called the vote first. But after that, everyone's voted once, so all the others should be coming back with false, which is correct. That is what happens. Okay, so the problem is I'm not handling the votes correctly. So, oh, I'm not sending votes into the vote channel, am I? Is that what the problem is? I think that could be it. So, so the votes need to be going into the voting channel, which is to say the receiver request vote. No, the request vote receiver replies with vote granted. That's completely cool. You know, it's done its job, it's replied, so the receiver's cool. The sender also sent off its stuff and replied, but the problem is, you know, the init candidate, the thing that, you know, did the request for the votes. Right, at this phase it requests votes, but then nowhere else am I even sending votes in. I'm not actually. That needs to go in the sender. The sender, you know, blocks until it receives a response from an RPC. And at the point where it does receive the response, it needs to send a vote into the vote channel that corresponds to that candidate. But the candidate's vote channel is unfortunately only available here. Okay, so yeah, I found the bug. The bug is effectively I didn't implement the step that takes you know, I've got the votes, all the votes are working correctly, but I didn't implement the step that I have implemented the step that collects votes, but I haven't connected that. So no, you know, I'm basing that on a votes channel, but I haven't I'm not anywhere getting the votes into the votes channel, and that's it's clear why I'm not doing that. The reason is I don't know how to do that yet. I need to fix that somehow, and I wasn't sure how. Well, I didn't realize I'd made the mistake, but it makes sense that I made this mistake. That's what I'm trying to say. Because the way I've implemented this, there is no way to connect the votes channel to the correct place. I think votes, we just need to pass a reference to the votes channel into the RPC sender and handler. Does that make sense? Like, it sort of messes, it fucks with the boilerplate slightly. So send append entries, you know, it has a destination, it has arguments, and it has a reply. But obviously this returns only once the, I should be looking at the vote count one, which is higher up. This returns only once the thing has replied, but it's at that step that the votes have happened, and I need to deliver the votes back into the candidate's routine. Which is, you know, I have a votes channel, but how do I send into the votes channel? Do I just pass a reference to the votes channel into send request votes, or would that clutter the code and make it a bit less? There'd be a bit less separation of concerns in the code, as it were. Because this is pretty simple for the time being. It's just the server, the arguments, and the reply. But, you know, the reply gets saved. Yeah, because I don't want to. The reply gets saved to a particular spot that is accessible within the candidate routine. But as you can see, we are not, you know, we have replies, we have space here where we can save the replies, but I have no way of knowing that a reply has come through. Without, I think, passing references to channels and things. It's a bit, yeah, sorry for being a bit unclear in my speech. It's just kind of difficult to decide which idiom I want when it comes to dealing with RPC replies, and so whatever decision I make now is going to end up sticking with me. You know, it's going to lay down my way of thinking about how to handle RPC responses. The thing is, so let me generally break it down and summarize. Just in general with an RPC, what the problem is, replies are received. You know, all of these RPCs, they have to be sent out to lots of different peers at the same time, and the replies are all saved somewhere when they come back. But the calling code doesn't know that replies has been modified without accessing it. This is what channels are for, because you can get the code to wait, basically wait for votes to come in or replies to come in, and that's what I'm doing here. This is why I have a votes channel that waits. Sorry, here. That's what I'm doing here. I have a votes channel that waits for replies to come in, but nothing is getting sent into the votes channel. Instead, all of the information is getting saved into the replies memory location, which this routine that we're working in, the candidate routine, does not know that anything has changed, and the only way we can alert it is to get the thing sent to votes instead of getting saved. And I know I can do that by passing a reference to votes into the sender. But should I be using excuse me. Should I be using the replies that have been sort of specified in the boilerplates here? Even though I don't know how to get information out of that because I have no way of knowing that this has succeeded. There's no channel to trigger when it is done. It just saves the replies to a particular location. This seems like a kind of general question that I could possibly find the answer to just by Googling a bit about Go in general. So that's what I'm going to try to do. I'm going to say Go RPC detect reply. Let's see if that gives me any information. Because don't forget, in the MapReduce project, we didn't need to save a reply at all. So we didn't encounter this problem. Alright, let's just click through some of these blog example. Yeah, classic Indian software developer. Let's just click through an example. So shout out to DistSys for providing what looks like an example. What I want to know is not, the RPC clients. This is what I want to know. How does it deal with replies? So you can see the call, where the point where the call is done, it has a reference to reply, and then it returns a reply. What MIT have been doing is returning success or failure instead. Yeah, no, my problem is 100%. I don't know how to handle RPC responses. I don't mean handle the reply phase. I mean handle on the sender side the fact that the RPC completed. I can obviously handle it within the sender code, but to deliver the information back, that's a bit of a struggle. Well, I mean, I think the problem is, the insurmountable problem is that I have to send loads of calls at the same time, and then wait for all of them to come back, and only proceed when all of them have done. So it's like that promise all sync wait group. Promise all in Node sync wait group in Golang. That situation. Although I'm not using sync wait group, instead I'm using an aggregate channel, namely the votes channel. I think that's what the problem is. You'd like to just be able to send off an RPC and then wait for it if you need to, but if you're waiting for loads of them, then they all need to be going in concurrent Go routines. And so you can't just return. It's not possible for a Go routine to return, I don't think. Because it triggers concurrently. So the line of code that assigns is not going to work. You can't return off a Go routine. I'm pretty sure that's not possible. Hence, I've been using an aggregate channel. So I think I might need to stick to that. Yeah, because this is all do a single call, wait, and then return. And then you can see multiplies, because it's returning the reply, multiply is probably not being run concurrently. Yeah, you can see that immediately here. It's not being run concurrently. So this is not helpful. I need to run them concurrently because I'm parallelizing multiple RPCs at the same time. So I'm going to do what I decided was really the only way to do it, which is to add an argument to send with the votes channel and ignore the entire reply struct because I don't see how it's useful. I'm going to leave it in the code in case I need it later, but for the time being, done.ch, the done channel, is effectively what we're sending into, and that is a chan. It's actually a pointer to a channel, but I think channels are never copied in Go. Done.ch is a channel of booleans. Done.ch is actually the voting channel. Right? Yeah, I've just noticed I'm looking at append entries. All in good time, all in good time. I should be looking at the votes. The send request vote. So this thing is going to have a done channel, which is the aggregate channel that I spoke about that tracks if everything is done. Okay, and the point is, sure, we return an OK statement, we run the vote, but the point is, okay, yeah, no, the RPC automatically stores the result in reply, so we do need reply to exist after all, because that's where the information is stored. But really it's important to then just immediately access the information. I mean, storing it is almost unnecessary. It's just a quirk of how RPCs are implemented. It has to be saved to a variable, the information. So instead of just getting passed. But that's fine. I've saved it to a variable. I'm just going to re-access the variable and we'll be on our way. So done channel, before a return happens, done channel will just, this is buffered so it should not crash, hopefully. That does make the code slightly booky, because if you accidentally happen to send bare request votes more than are necessary, then the code could easily deadlock at this phase. There's no timeout in the sender. It just has to pray that it can send into the aggregate channel. Slightly dodgy, that. Could deadlock. I'm just going to put that. Do we have any assertions that guarantee it's not going to deadlock? Well, no, because... Well, yeah, I guess we just have to make sure that we do not... A single candidate does not trigger lots of votes at the same time. Oh no, do you know why it's fine? It's fine because we define a new define channel a new done channel every round of voting. So here, send request vote. Votes is defined every time there is a new round of voting. We for loop to send to all the relevant places, but then there's no way that the code is going to jump back in here without making a fresh voting channel and sending a reference to it to send request vote. Okay? Understood? That checks out. So we do have an assertion within the caller, which is a bit dodgy. I'd rather the assertion were, the safety were within the sender. But the thing that calls the send routine is safe, because it makes a voting channel of length the number of things that are iterated over to send the RPCs, and then each RPC replies by sending back into votes, and then the code continues, and so every time this is called there must be a new voting channel defined before the loop, so that assertion means that it should be fine. Okay, let's see if that works. Some madness is going on here. Lowercase field entries of append entries args. This is a will break your raft. This is just something, yeah, I've gotten a warning here that I'm just going to fix straight off the bat before I check if the rest of it has actually worked or not. I don't think it has, but basically the append entries structs, they must have capitals. They just must. Everything must be capitalized, which it is. So let's try that again. Okay. Two becomes a leader. So the vote has succeeded. You can see 2 makes itself a candidate after a timeout. You know, it requests votes from 1 and 0, and 1 and 0 votes true. And so 2 is the leader. That's actually succeeded. Right, the candidate code then exits with in its leader run. So 2 is leader now. Whereas 1 and 0 are hitting resets. 1 and 0 are hitting reset because 2 is a leader. So, and 2 is successfully heartbeating if it is triggering 1 and 0 to keep resetting. Okay, but then it's saying expected 1 leader and got none. Even though 2 is clearly still a leader. Surely. Surely this is now fully working. Why would it not be working? It's saying again, it's saying expected 1 leader got none. I need to modify the tester code because this is not clear enough. You know, the way I have written the code, yes, 2 becomes a leader. And then it goes into heartbeat mode. Which is totally correct. 2 is leader. Is leader returning true? That's the important thing. What was it called? You know that API, as in the interface function, that checks if something is a leader and checks what its term is. The sort of introspection function that's included in the code. What was its name? GetState. Yeah. Here's your mistake. This is capitalized. It should not be capitalized. But no, I think that works. Watch this. Oh shit, servers disagree on term. That's the error we got out of this. And the error after network failure that we got is that we have 2 leaders. Okay, we've made progress. Good. So we have successfully, as you can see here, elected a leader. Look at this though, 0 timed out before 1 successfully became a leader. So 0 became a candidate and then started requesting votes. Zero became a follower at this point because even though it started requesting votes and it received some votes later on, it doesn't matter because it immediately turned into a follower because it received a heartbeat. The same thing that reset to was received by 0 here. So I'm not actually tracking append entries messages at the moment. I should probably put that in just to make the code highly debuggable. I think that's going to be useful in the future, so I'm going to do that now quickly. I'm just going to put these kinds of RPC messages in for append entries as well. I'm just quickly going to do that now. So this is append entries. There's a lock, a term, Interesting, I'm looking at my append entries. It does not even involve an RPC call. Instead, I am sending into election resets. Oh, this is the receiver, sorry, I got confused. Yep, so I'm just going to try to mimic the codes that I had for the request vote sender, which is this, and put that in the append entries sender. Append entries args candidate ID to server. Yep, again that checks out. It's not candidate ID, it's leader ID. And the receiver is going to have a, let's just copy the code straight out of the request vote receiver. Yep, just before the lock is dropped. Just making the code a bit more introspectable. Args candidate ID. rf.me and reply.success, I guess. Doesn't really matter because we're only doing heartbeats. Doesn't really matter what the reply is. Shall we save output to out? Just to make it readable? Let's do it. I like their idea of making an out file to store output into. I quite like that idea. Even though it is annoying to have to keep looking at the other test, I would rather it only ran one test, but yeah, never mind. So look at this. You know, followers 0 times out becomes a candidate, does voting, gets true, becomes leader, sends append entries. You know, this triggers a reset of election term in 1, the 2-1 triggers the same thing in 2. So it's working. The problem is the servers disagree on term. I think we need to implement RPC term sync after all, because it seems to be failing the tests otherwise, even though yes, I do have one leader. I have got one leader elected. It's nonetheless failing. Whoops. Wagwan. Position myself into a slightly more comfortable position. I have to keep rolling off my butt constantly, so that I don't get a dead ass. Okay. Let's implement RPC term sync. Something I've been trepidating around doing, but I think it is necessary to have it because otherwise things get messed up. Every time there is an RPC, a term sync must happen, okay? Let's just go into the outline of 2A to get an idea of how this works. If current term is less than the term delivered by the RPC, then current term is assigned and the thing becomes a follower, okay? Those two, that idea, and this happens both at the send and the receive end of an RPC, right? This comparison. So first, logically, this means we're going to have to implement the code in 4 different places. Logically, the first thing that happens is sorry, it just started to cross my mind that I have to be careful that if I send RPCs and there's a phase change that is done by an RPC handler, that means that all of the routines that correspond to a particular phase exit correctly. And that's happening here, for example, because I'm checking explicitly before doing the routine again that the thing is still a leader. But, you know, for like follower and candidate, I have to be a bit more careful. But becoming a follower is fine. If something is already a follower, yeah, but I mean, no, this still has to exit, and we have to be very careful to basically not have 2 copies of follower and leader code happening at the same time, in like the candidate code and that kind of stuff. You know, if something becomes a follower in the middle of sending and receiving RPCs, that could mess things up. So those 2 things I think I have to bear in mind, get them straight, and then once we've done those, I think we're sailing ahead. So just got to be a bit careful. Yeah, I'll make a quick note on my stream that I'm doing implementing RPC term sync. My IRL text. It's still called that. It's not IRL anymore, but you take the point. Funny having to edit the stream live on the stream, but it seems to be okay. Doing RPC term sync, that's what we're about now. So to start this phase, I think I might end up splitting the stream here. What I am doing now is part of the Raft protocol. That's quite an important part, and I continually said it was an important part. Now I get to prove to you that it was indeed an important part of how Raft works, is the synchronization of terms every time an RPC is done. It's written here. If RPC requests, so this is the blueprint from the Raft paper, figure 2 in the Raft paper. It says here, if RPC request or response contains a term bigger than, you know, the self term of the thing that's received or sent, then we have to set the self term, update it, and convert the thing to a follower. That's what I still haven't implemented that because I wasn't sure it was necessary for 2A, but it seems it is because I'm getting term disagreement failures in the tests. So you can see it here. You know, servers disagree on term, right? So I need to keep the term synced by implementing that handshake protocol. Every time an RPC happens, there is a handshake in which terms are synchronized on both sides. And the thing is, every time something has to appear has to update its term, it has to auto-convert to follower. And it's slightly difficult to do that because it's a kind of override, and you're not sure if, you know, the code is in the middle of something else, where the code is. The server could in principle be doing literally anything, and it needs to be in a position to quit out of that ASAP and get back to just, one loop of being a follower. Wow. Oh no, I can still hear the fan, it's just very quiet. Well, because I have the window open outside. So that's what I need to implement now. So I have to be careful both to implement the RPC handshake correctly and also to make sure I quit out of any routines that if there is a change of phase. But also, I mean, if something is already a follower, then it's calling a, this election reset code. This needs to be, I think, restarted. If it's already a follower, then we probably should not reinitialize follower after an RPC handshake. We should just update term and leave it to continue doing what it was doing. But in any other situation, it needs to be able to switch to being a follower ASAP. So let me try to implement that way of thinking first. Okay, so if the thing is already a follower, I'm not gonna reinitialize it being a follower, because if I do that, then I have multiple loops of this, which sustain themselves even if I trigger the next loop if the thing is still a follower. I have multiple loops that sustain themselves of this waiting for an election reset or triggering a timeout, which means you have multiple timeouts going on at the same time. So yeah, under no circumstances should init follower be run twice. What I could do actually, which would make this very neat, is quit the init follower routine if the thing is already a follower. Which kind of involves running, I mean, init follower should be run by make in the first place, but the state should not be initialized to follower, it should be initialized to a null state, so that when it becomes follower for the first time, this works, and otherwise it quits. Okay, that's what I'm going to do, because that way I can call, liberally, I can call init follower anytime something should be a follower, anytime the peer should be a follower, I can call init follower, the follower initializer, but this must not happen more than once. And so all I have to do is return immediately. Oops. All I have to do is return immediately in the event that it's already a follower. So that's what I'm going to do. Let me just make sure I get the code right so I don't lock permanently. I have to be able to unlock in the right place. And I'm not using defer. Defer would make me safe, that I always get, because defer runs a piece of code after a function returns. So if I use defer to unlock, then I could have the lock during the entire function call, but that means I'd have to split this up, and if I don't want to do that, maybe it's best to split every lock phase into a separate function, but I don't want to force that upon myself, so I'm not going to do that. Instead, I'm just going to pay attention to lock releases, be careful. So this is what I'm going to do. Current phase var current phase string. Then we do a lock. We say if current phase, because init follower is only run when the thing needs to become a follower. So what I'm saying is if current phase is already follower, is not follower, then what I'm going to do is set it to follower and continue, okay? Else, I'm going to return. So there is this function should not run if the thing is already a follower. Never re-init follower. Okay? Never reinitialize a follower. Okay, the problem with this is, of course, what's going on with the locking. I'm going to put the print statement here. The unlock has to run as a kind of finally to this if. How can I run a piece of code as a kind of finally to if? Because I have a return here. I think we need a bit of code redundancy, unfortunately. I don't see how to avoid that. So it's not really a big deal. Just make sure you unlock in both cases. You know, we do the comparison and we do the reassignment here. Yep. Yeah, no need for this after all. So there are two exit points. This is the important thing, right? We test if it's a follower. If it's not, we set it's a follower, print it became a follower, and unlock, and then continue. Else we unlock and return. Okay. Both cases it's imperative that we unlock. But here we assign and continue, and here we return, and they're slightly out of order from each other, but that's because return is always the last thing that happens in a function. So yeah, just got to be a bit careful about that. Should I refocus camera? Seems to have not gone to sleep. That's interesting. Well, should be all right. All right, check it. That's fine. In the case of leader and candidate, let's also just be very careful that we don't run loop codes multiple times. The point is, there is a chance that during any RPC, a thing has to become a follower, if it's a leader or a candidate. If it's already a follower, we just call init follower and it continues along its way because it's already a follower, and so it just returns. The init follower doesn't succeed. That's totally okay. In the candidate and leader cases, we have to be more careful that we can cleanly continue testing whether it's a leader or a candidate still before doing anything. And quitting. Make sure you quit. If not, okay? Just want to watch out for memory leaks. But as long as every Go routine is short-lived, I don't think there will be memory leaks. Gotta be careful though. So candidate phase, for example. Well, there is a straight-up lock until all of the RPCs have been sent out. Okay. But this is the thing, RPCs have been sent out, the thing could easily become a follower at this stage, okay? So we have a select statement that counts votes. And it gets converted into a follower if an election reset happens. But that's not logically the same thing as a reset, as in conceptually it's not the same idea as a reset happening because of an RPC term synchronization that the self lost out on. But I mean, init follower and return, that checks out fine. Otherwise, because all of the RPCs have been sent, they've definitely been sent. Okay? We have lots of RPCs. Even if one of them triggers a follower, the thing's to become a follower, we can still quite happily count the votes. That code is not dangerous. we can still quite happily expect an election reset, which will trigger it becoming a follower anyway. But we have to be careful here to ascertain that the candidate is still a candidate before rerunning any of the code. But this is the exit point. We can just run init leader and init candidate and put in assertions at the beginning of those for the thing to quit if it's not a leader. And see, there are multiple ways of doing it. We can get the leader codes to quit in the event that it's become a follower in the meantime, at the very beginning of the leader code. And we can get candidates... Well, no, we can't really. Oh, God. Dear. Maybe I should, switch my position up. Sorry, I've definitely squished. I've got a very dead arse at the moment. This dinging is starting. So I'm going to have to rotate slightly, contort myself. But this is a totally chill position. I'm completely happy with that. Check it out. Okay, center it. Sorry, nudge the microphone. Center it and then refocus it. Okay, all good. No, I think we should be looking at clean exits instead of clean entrance. The reason being, we want to end a routine if something has become a non-follower routine needs to be ended as soon as possible. And so it's better to cut it off before it launches into another one. So I would say here, check if it's still follower. Sorry, check if it's leader or follower. This is totally synchronous code, isn't it? No, it's not, because it waits on votes to be counted. So yeah, at this point I'm going to do a lock and unlock check. Am I still candidate? These are Go routines, so we are allowed to trigger them without the lock. It's not going to cause a performance problem, because they go off in a separate direction asynchronously, and then the unlock happens before the return. But the point is, why do I have an unlock here? Because I want to access state. If rf.phase is still candidate, right, and vote count. So this is explicitly detecting if the thing has changed and is no longer a candidate because it was turned into a follower by a RPC handshake failure on its part, as in its term was not synchronized. Okay, that's what this is explicitly checking before it even launches the next bit, and if it's not, it just exits straight out of the candidate code, which is good. So let's just implement that on the leader side as well. I already have basically implemented the same idea in the leader section. You know, init leader is only ever going to be called out here. This is the only entrance point to something becoming a leader. That's forever. It's going to be like that. So it's definitely a candidate at the point where init leader is called. If it suddenly changes in the meantime, I'm not going to check again. Instead, it will be a leader for a bit. You know, and then it starts doing leadery things and runs a heartbeat. No problem, runs a heartbeat. This could also cause it to turn into a follower, this section. But that's fine, it just sleeps for the heartbeat timeout and then checks if it's still leader. Checks if it's still leader at this particular point. So I've had to write the lock and unlock in this way here because this is not getting triggered in a go routine that leaves the lock. It's getting triggered within the same strand of code, and so if I unlocked afterwards, the whole next heartbeat would happen before the lock, and it would lock itself because it would try to take a lock that's not available. Just recursively, it would keep trying to take a lock, and so it would just immediately jam. So I had to do it this way. Okay, I'm kind of happy that that code is fairly robust now against state changes. So I've implemented, I did this state change thing in the leader yesterday, and so I've just carried over similar ideas to the candidate and come up with a new idea for the follower, which is to say, if it's already a follower, do not reinitialize follower, just quit, return immediately. So with that in mind, I'm now going to implement the RPC term handshakes themselves, okay? So let's begin. Let's go with request vote handshake first. So we start, the code sends off the RPC and then we get request vote. So term sync, here it is, let's do it. If, so yeah, we're within the lock still. If this whole thing is going to be within a lock, so do you know what, perhaps I am going to defer an unlock just to be absolutely certain that the unlock does happen when the handler exits, no matter how it exits, even if I return here. It's an interesting idiom, not present in other programming languages. Can add complexity and confusion if you're not careful. So I'm hoping, even though I am mixing and matching using defer and not using defer, I'm still hoping that it's going to stay fairly clear. Next fly. Wagwan. Guan fly ting. Term sync happens here, okay? We do the check, which is the self earlier than what it received? If it is, the self assigns to the latest term. I become a follower, and yeah, I stop handling. Oh, I don't stop handling the return. The thing about request vote is that yeah, the thing about request votes is that if the thing is already a follower, the code should continue. If it is a candidate, in principle, maybe it shouldn't, but it's not actually a problem if it does, because all that it's doing is it's voting. It's replying to the RPC with a vote granted and a voted for, right? So it literally just replies to the RPC. This is the only thing that this is doing. All that request vote does is it replies with a vote and sets its own voted for that term. Oh shit, but current term and args term, oh yeah, this is out of order. No, the voting session is called for the term that is passed in. Oh, but no, it's called for. Oh, no, this is the correct way around. Yeah, believe it or not, it does make a difference which way around term sync and payload are, okay? Again, watch out, watch your ass. Why does it make a difference? Because the vote should be happening on the term specified by the thing that called the vote. Right, so voted for is a variable that needs to keep getting reset every time there's a term increase. Ah, shit, so yeah, here we need to actually reset voted for. Wow, you've got to be careful. Voted for is reinitialized to -1. Every time the self increases its term, the voted for variable has to get emptied out. So maybe I should bundle these into a separate function, possibly. That could cause confusion. For now, I'm going to hesitantly leave it. But that's the point. So this is a term reinitialization. Voted for gets set to the right thing. And now the term in principle agrees with the term of the argument because there's a lock. You know, there's a complete lock here. The term should agree with, yeah, the term throughout this code agrees with the term that was received by the thing that requested the vote. Well, not necessarily. If self term was less than the candidate term, so this is the voter. If the voter's own term, the self term, it was less than the candidate's term, then it gets updated and the voter is saying, okay, I haven't voted for anyone this term. And so then it just continues. It sets itself to be a follower, fine, but it continues with the vote, does the vote. Okay? And then this is definitely true, and so it votes, and this is also true. So it actually does reply with a true vote grant in any case, and sets its voted for to this. I guess I could, if I wanted to, short circuit the code, and put that if the term sync fails, then I'm definitely voting for. Not definitely, because it has to synchronize logs when we implement data. At the moment, it will always happen that way, but in the future, yeah, because we need to implement another test, we need to keep them split apart. So this is what I mean. Vote should also depend on whether the logs are synced with each other. Complicated, isn't it? That's okay, that's fine, no worries. But yeah, there is also the case where my term, the self term, is greater than the voter term, in which case I am not necessarily a follower. This does not run. There is no resync. My term is ahead, so I'm not going to edit my voted for either. Instead, I'm just going to, this is going to fail. Because my term is strictly bigger than the candidate's term, and so I'm just going to reply with false, which is fine. So that's fine. That is on the receiver end, I have implemented the handshake and the follower and the voted for reset. Yeah, but like whenever there is a, I think maybe I do need to run a set term, because this block of code here is going to run over and over again. Maybe I should chuck it in a function. But no, I'm going to leave it alone for now, just for now. So let's try to chuck this into the sender as well. The sender needs to do the same thing. You know, the sender, the thing that requested votes, it forwards all the votes into its vote aggregation channel. And let's say after that, I think after that is fine, we do RPC term sync. Yeah, I'm going to put RPC in just to make it clear. RPC, it's all about RPC term sync. It's just the RPC meta, the term sync meta. So we need to run an RPC term sync here. I know, where have I copied that? I need to copy the entire if block. And try not to press Z without control, because I'm using my middle finger on control, so I keep missing the control button. Sorry, my little finger, yeah. Pink A. Yeah, the sender doesn't even have a fucking lock at this stage, but because term sync is so important, the lock's gonna have to drop here. So let's lock. And let's defer and unlock. So notice the locking is waiting for, you know, it's outside of the RPC wait where the lock happens. Again, I'm using defer idiom here just because if ref current term is less than not args.term but reply.term, it's set to whatever reply.term was. It's voted for, is sent to -1, and it becomes a follower. Okay, that's despite sending a request vote to RPC out. Yep, and because of the way I defined the candidate code, it will, in principle, even before this is returned, it will get assigned to follower. There is a possible bug here that this stuff executes slightly out of order. Imagine if, sorry, where, got it clear, okay, up here. Imagine a situation in which a send request vote replies to a candidate. Sorry, as in the candidate itself is running its own send request vote. So, you know, the vote gets sent into the aggregation channel. And then the term sync does not happen. So before the aggregator moves on and turns into a leader. But then before it becomes a leader, it gets converted to a follower. But then it goes automatically from follower to leader because it jumped into a new go routine. Okay, I think the way we're going to fix that potential bug is by ensuring that nothing becomes leader if it were not already a candidate, okay? So, if rf.phase is candidate, then it becomes leader. We just run the full leader code. Else, we return. So the point is we cannot assume that between the candidate calling become leader, so it could still be candidate here, but then it calls become leader, and in the meantime it could get set to follower, and that could get overridden to become a leader again. So that's why we cannot assume that it remains candidate from this phase where this got triggered, the leader turning into a leader got triggered. And by the time the leader code runs, because it's running in a go routine, you see the go there, by the time the init leader code runs, it could have been converted to a follower. So we need to check again that it is indeed a candidate before turning it into a leader. Okay, it's just some safety measures, just to deal with, you know, nasty race conditions. I really do wonder how the race condition detector works in Go. It probably just runs the code lots and lots of times and sees if there are like state disagreements or something. Don't know, man. So send request votes has now been implemented. You know, the votes have to first be sent out, and then we have to deal with RPC term sync at the point where the reply has come through. I think that's fine. Well, that's the request vote now synchronizes RPC term. Sorry, terms. As in request vote is an RPC that now synchronizes terms. We need to make sure that send, the other RPC, does the same thing. So again, jumping straight into the handler. Append entries handler is run by a follower, or indeed a candidate, whatever it is, it's run. But, so yeah, the same kind of code is going to work here. What happens here is we have our reply.term What the hell is this? Append entries sets the reply term to be its own term. That's some very dodge code. What? Why did I write that? That's highly dodgy. That could violate a number of assertions. The point is, append entries, the handler for append entries, sends a message to its own election reset. That should happen regardless of whether term sync happens or not. And then this is some code that's not actually important for the time being, whether it's successful or not. And this just says that it ran. I would say run a term sync and become a follower. No, what? I don't know what that line of code is. Sorry, it's just fuck knows. Let's try to copy it out of how we did request vote. Let's do an RPC term sync. I have the same thing here. Reply.term. Oh, reply.term. Sorry. Wait a second. Oh, right. It assigns the term of the self term to the reply. The self term. Okay, this is the thing that's responding to an RPC. What I'm about to say applies to any RPC that's doing term synchronization. The self term needs to first be updated and then it replies with its own self term. Obviously, yeah, it should be replying with a term after it has updated its own term. So this line of code, reply.term is, by the way, not touched anywhere else, so I think reply.term definitely should just happen at the end. Print statements, either way. But yeah, reply.term should definitely be assigned at the end of any term synchronization. So let me implement that in the request vote one as well. So this, yeah, definitely has to follow RPC term sync and payload. You know, send back what your term is as late as you possibly can so that you have time to synchronize it. That's what I'm saying. So I think this RPC term sync code goes unchanged into the append entries handler. Well, the question is, where do we put it? Answer, I think we want to send off an election reset first, because election reset has the effect of maintaining followerness. We generally in Raft want to keep things followers as much as we can, keep things stable as a follower. Every peer should be a follower, unless it's absolutely certain that it should not be a follower. Like if a timeout happens, if append entries have all stopped happening. So in this case, definitely append entries is supposed to keep things follower. So we do want to send election resets even if, no matter what happens afterwards, just as a kind of concept. And no, I think maybe it doesn't even make that much of a difference in this case, but like, yeah, definitely. It's code that's safe to run as soon as possible. That's what I mean. The election reset, whenever the heartbeat happens, is detected. So if my current term is less than the arg's term, then I reset and I reinitialize myself as a follower. What about payload? Well, this is again a question of just replying. So it's absolutely fine for that to happen as well. But I'm resetting myself to be a follower. It's like a follower interrupt. Yeah, just difficult implementing that correctly. Okay, append entries and finally send append entries. So again, it's a question of receiving. So yeah, I am gonna after all write it this way. Oops. Just so that I have a bit of space to include term sync. So term sync on the send side, I'm going to just prototype that out of the send request vote. No, I am copying the code verbatim, which is why I am thinking maybe I should split them into like a send and a receive RPC term sync. Send side and receive side. You know, necessarily there is a lock and an unlock. Check your term against the reply. If the current term equals the reply term, become a follower. Which is interesting because send append entries, of course, is something that only the leader does. So here I'm saying become a follower, but the leader code will literally persist. It doesn't block. It doesn't. Do you know the thing about send append entries? Again, we have to do it via aggregation, but I think the leader can happily wait for all of this to come through before it sends off the next piece of information. But I mean, if there's a failure, it should perhaps time out. So there should be a heartbeat timeout. That's a little bit. Let's not get ahead of ourselves. I'm not gonna think too hard about that for the time being. Instead, just you know, because we're not doing data phase yet. In the case of the heartbeat phase, let's just keep the heartbeat ticking off. Asynchronously send off. Oh shit, hang on. I'm sending bare RPCs here, but I'm doing them all sequentially, which is a mistake. Yeah, that should be go. Didn't notice that bug. So this immediately returns, the code immediately continues into a timeout, and it just makes sure that it's still the leader before sending out any more heartbeats, which I think is pretty legitimate. So just every time the leader does something, check if it's still the leader first. That's totally cool, doing that. Because if it's not, the thing just quits, and at some point it will have been reinitialized as a follower. Or a candidate or whatever. You know, init follower and init candidate are the only, and init leader. All three are the only piece of code that is allowed to change the state. That is an assertion that I'm using. That's allowed to change the phase. So we can be sure that those bits of code are running if the phase has changed. Which is why I'm happy to just quit this code out whenever the thing is not a leader. And run whatever. For now, I'm just calling heartbeat in the same thread. Wow, guys, that's it. I've implemented something that I think is quite difficult, the RPC term sync. So the synchronization of terms, you know, the things agreeing on which voting term they're on, every time there is an RPC, both on the sender side and the receiver side. Not easy at all, but I think I have done it correctly. Because it required me it requires sending interrupt, become follower now, and cancelling out of whatever the candidate or the leader code is if it's doing that. So I think I have implemented it correctly. And also had to make sure it's doesn't run the follower code twice, or else it's going to have two loops waiting for timeouts, and that's going to fuck everything up. So you take my point. Whoops. Wow. What just happened? So let's see if that works. The fact that I'm doing this, I don't think it actually replaces the file. Unfortunately, I think it might just jam the results onto the end. Yeah, that's probably what happens. Oh shit, wait, no it doesn't, it actually, it passed. Oh my god, the anticipation scrolling down to see if it passed. It's sending so many heartbeats, and this shit is barely even replying to them, which is interesting. It just keeps sending them and not receiving replies. Fail. Expected one leader got none after a re-election. But something is sending out append entries, so surely that's not true. Okay, it passed the first test. If I can just get it to pass the second one reliably, then I'm gonna allow it and just. Life on the ends. So yeah, the re-election test is failing for some reason. Do we have any idea what's going wrong here? You know, again, it's saying expected one leader and got none. So here, let's try to follow the code in the failed test. 2 follower, 0 follower, 1. They all start out as followers. And 0, despite being a leader, is firing off, despite being a follower, is firing off append entries for some reasons. Any idea why that's happening? That's clearly a mistake. Is that also happening here? No. 0 was elected leader and then it started firing append entries. Why then is, when 0 is a follower, why is it still sending append entries out? What? This should only be happening, I mean, you know, 1 timed out and became candidate and then became leader. Yet append entries is 0 to 0. Wow, your code is messed up. 0 to 0. RPCs definitely should not be sending to them, you know, things should not be sending RPCs to themselves, so something weird has happened here. My heartbeat codes is just running for 0 for no reason. Mate, what? Alright, well, you know, I'm going to, once I've finished this, I think I am done for the day, once I've debugged fully. So let's hope that we can get this out quickly enough, okay? I'm hopeful. What the hell was that error? It's like, that's just weird, isn't it? It's like, so again, let me just delete the past test. What do I want to do? I want to go like Shift Control FN Home backspace delete save. Okay. Why is append entries being sent out by 0? Hang on. Was 0 the leader last time? Yes. Did it not terminate the code fully when it ran the next test? I mean, it's definitely not my fault if it's doing that. What? God, that is particularly weird. That's very dodgy if it's the case. Again, it failed to copy for some reason. Go test run to. Which test do I want? I want the re-election test in isolation. No. 0 is definitely firing off append entries repeatedly for no reason, even though 2 is claimed to be leader. You know, nothing is leader at this stage because 0 is constantly firing shit off. It's not clear why that's happening. Well, no, I'm looking at re-election. Go test run re-election to a election after network failure. They're all followers, 0 times out candidates itself, becomes leader, sends off append entries, all of the others keep getting reset. And then there should be a network failure somewhere. It's a shame that it doesn't log when the network failure happens. But like, yeah, it just disconnects them all. So, you know, these are replying fine, and then 0 sends off instructions. 1 times out becomes a candidate. 2 times out and becomes a candidate as well, but at this point 1 has received a vote from 2. 2 has received a vote from 1. That's a term discrepancy, isn't it? I need to definitely be logging which term the things think they have voted in to be able to follow what's going on, but then 0 just continues sending off stuff and failing, so nothing is receiving from 0. 1 becomes candidate again. Okay, this time 2 has actually, you know, it's voted, and it has also become follower because it's probably because its term is out of sync. So I'm gonna have to debug that as well. 0 is still failing, sending shits out. 2 timeout candidates. Oh yeah, 2 becomes leader here. But then what happens? Does 0? Check the chat message quickly. Hello, enjoy stream and programming. Thanks very much. Trying my hardest to, well, debug can always be a little bit frustrating. At the moment it's not that bad because I've only really had this problem for about 5 minutes, and it's quite a wacky one. Doing my best to figure it out. So the idea with this test is that 0, which was the leader, so 0 is the name of the peer, was the leader. It got disconnected, but it's still sending heartbeats out to various things, including fucking itself. Somehow, it's just chaos is going on here, to be honest. And you know, 2 became a follower. Sorry. What? No, there are various things that could be the problem here. But I think most of all, the fact that 0 keeps sending stuff. Does some of the stuff from 0 arrive? Some of it does, as you can see. You know, 0 received a reply from 1, and maybe 1 became a follower again, but 0 is still remaining leader. I think, okay, if I had to guess, I would say the biggest problem that has not been dealt with yet here, that's causing causing trouble, is that 0, despite not being leader anymore, continues to send append entries out. So append entries, that particular RPC remote procedure call, is only something that only the leader should be doing, ever, right? Let me just check my camera position there, yeah, just chill. It's something that only the leader should ever be doing, okay? But this thing got disconnected from the network, something else got called leader, but like 2 here becomes a leader, for example, and then it immediately gets converted to a candidate from being a leader. How? Why? Man, that is messy. Why does 2 become a candidate? You know, it was leader. How does it go from leader to candidate? How can that possibly happen in any situation? 2 fails to send out a single heartbeat. Instead, you know, it enters here. gets assigned to leader, and then heartbeats. Init leader should not ever run again. Well, it should exit out if it ever does run again. So what I'm saying here, 2 is now leader. Okay. It runs a heartbeat. Well, it tries to run a heartbeat, but it fails to send out a single append entries. But somehow it just becomes a candidate again. So there's a bit of code that's running concurrently that resets it to candidate even though it's leader. So the point where it can become a candidate is in the candidate initialization, and the point where that can be called, well, the only time that should be called is during the follower phase. Or, indeed here as well. This is supposed to be tail recursive, but I think 2 became a follower at some point here. But then it got reset to leader while the follower code was still running, so maybe the follower code needs to be in a position to exit as well. Let's do a for loop. This is again just a safety assertion. Let's do a while loop. So again, while loops in Go are written using for loops, literally just have the condition. So every time the for is run, but we need the lock if we are going to get states. God, part of me wants to ignore using the lock in order to read state. Is it really necessary? Just do an atomic read. It might be. It might deadlock. So I'm going to stick to the advice, which is use a lock even if you are reading. Honestly, man, I think probably the best way to do this is to ditch the entire for loop and make it tail recursive. Which is what I said I would do earlier, just to make the code more consistent. Possibly. I said I might do that, but I think it's actually necessary for safety to do the follower test. Oh yeah, I think that's it. It's necessary for safety to do the follower test at every step of the loop. Even though it was really only intended, the follower test was only really intended to make sure we don't start multiple of these loops. But what I'm saying is it's probably best to do a follower test regardless, even within a single loop, so that it exits out as soon as possible if it's not a follower anymore. Something along those lines. Let's implement that. Let's do it. So I'm going to convert this, instead of doing a for loop and resetting timeouts, I'm going to instead have it tail recursive. Oops. So yeah, I'm going to have it run loops. Ugh, sorry, I'm getting hungry again. That's probably why my ability to explain is going down again. It's always what happens. But yeah, what I'm saying is I'm going to convert init's follower. Instead of being an infinite loop here that waits for, break restarts the loop, that waits for an election reset. Sorry, it waits for a timeout. Instead of doing that, I'm going to make it tail recursive, which means that it continually checks if it's a follower, and if not, returns anyway. Okay, so let's do that. Well, the hint I gave myself, make it tail recursive, I'm going to do that now. So first, step 1 is remove the for loop, the infinite loop. So this is now only one step of the loop. It runs a single select case, and if there is a reset, we just run init follower from scratch. Yeah, but no, that doesn't work. The way I have phrased it, it's not going to work because this init follower is only supposed to happen once. So instead, I'm going to need a new function, I think, to run an election timeout. Yeah, let's just get on with it, implement a new function. So I'm splitting the code up into two pieces now. Right, what this is going to be, I want this bit of code to be separate into a new routine, into a new function. I'm using, routine as a name for a function that does stuff rather than is intended to return values. Like in my very first stream ever, my first MapReduce stream, I was talking about pure functions. And how those return the same value always, and routine is kind of like a completely impure function. It returns nothing, it just does something, has a side effect. So it's the opposite of that, and those are, routine is a kind of way of describing that. It's a nomenclature, I guess. It has that connotation, yeah, for sure. So yeah, I'm running this, which is the kind of election timeout routine. I'm going to call it something along the lines of await election. We're waiting for an election. As a follower, the follower awaits an election. Using this shit. So I'm going to, call that here. And jump into this block of code. And so the point is, this code is now a bit more split up, and I can loop it back onto itself. So it selects a timeout. If the timeout happens, okay, we print timeouts, we run the candidacy routine and return out of this loop. If not, instead of breaking, we just run the await election routine from scratch. So this is the tail recursion. Tail recursion, the end of a function, it calls itself again. So this is in the end of the function in the case that it receives a ping. It just calls itself again. A ping being receiving a message in election reset. And those are run in separate Go routines always. That's fine, I'm happy to do it that way. And so we run await election when we initialize as a follower for the first time. No problem. And now just to make the code neater, I'm gonna split that up into its own Go routine and do an unlock. Let's again just defer an unlock. We may as well. Fucking keyboard is really a struggle. Well, any laptop, the keyboard is to some extent a struggle, to be honest. So the follower initialization locks and then unlocks when it ends. If the phase is not follower, should never reinitialize follower, so definitely only call the election if it's not already a follower. As in call await election for the first time. No need for this anymore either. And then await selection does a timeout, and this code does not need to be locked at all. It doesn't. Oh yeah, it accesses rf.me, doesn't it? Yeah, but that's because it's within my print statements which are going to get removed later on. Hopefully those are not causing bugs. They might be, for all I know. My print statements, bloody hell. You know something, the print statement, I can literally just... Oh, but it's an alias to print learn. What happens if I, instead of making it an alias to print learn, if I want it to do nothing, I would instead make it an alias to like an anonymous function that does nothing, something along those lines. Okay, so I've implemented my attempt to fix this problem, which is make sure you quit the, keep testing, am I a follower or am I not a follower? Keep testing that and quit if I'm suddenly not a follower, and that's in the await election loop. Run another await election, run an init candidate if it's time to become a candidate. But in either case, await election should only run if it's a follower. If not, quit. I think. So that we don't have something that assigns it to leader. Okay, yeah, let's just do that here. It's another safety measure, slowing down the codes in order to make it safer. If rf.phase, I'm not using get states to get the state, I'm using phase. Maybe I should use get states instead, because then there'll be less redundant code probably. If rf.phase equals not equal to follower, just return. Don't be running this loop. Finish it. Okay. Go test run test re-election 2A. I mean, append entries, it passed. What changed? Well, I guess there must be a leader now. I'm not seeing through the code well enough to really know if, to really be able to be sure if I correctly identified the problem, if I fixed it, if this is all how it's supposed to be working. Let's try to read through the code and reason through it to see why the test passed, okay? So they all start out as followers. One times out becomes candidate, gets elected, and then sends these out, the append entries heartbeats, which continually reset 1 and 2 and keep them in follower state. That keeps happening until at this point it cracks and stops happening. 1 times out and becomes candidate. Request votes from 1 and 0, from 2 and 0. Wow, that is a massive bumblebee thing. Okay, it's sort of gone, but if that enters this room, bloody hell. Judgment Day will descend upon my room. I did have a friend who, his mini shoebox room at university, he just, a bee would come in and he was scared of bees, and so he would hide in a closet while the bee left of its own accord. And he once hid in the closet for over an hour, and he just said, "There was a bee." Poor guy. Imagine all the stuff he could have contributed to society in that time. Yeah, because he topped my year for maths, the Cambridge maths course, 250 people, extremely hardcore course, and he came first in that course. Yet, he wasted an hour every now and again because there was a B. Fair enough, I guess. So where were we? Okay, it breaks down here. One becomes a candidate, requests votes. This doesn't even reply with a vote. Doesn't matter, it will fail because it has timed outs. Maybe I should do a timeouts a print statement for timeouts, I don't know. But yeah, basically. Yeah, it's checking everything's in order. Basically, this thing votes for itself. Sorry, one vote has already voted for itself. Two votes for itself as well. Sorry, two votes for one as well, that's cool. Then append entries happens from 0, these do not get registered. 2 times out becomes candidate, runs votes itself, 1 votes for it, and then 1 is suddenly a follower because of the election term desynchronization. But then 1 times out becomes candidates, and then 2 becomes follower. And then finally 1 becomes a leader, despite the fact that it had all the votes in the first place. So I think that's a priority error in the code. Maybe the timeouts are not long enough. So it's taking multiple rounds for the election to happen. It's kind of a split vote situation, despite the fact that, 1 timed out became candidate. It got all of its votes, but then 2 timed out immediately after. Yeah, so I guess what this means is they sort of called an election at about the same time. One really silly way you can get them to desynchronize is to use a kind of like a hash. Instead of using randomness, use a hash that depends on the number of the candidate. Get some permutation that changes randomly, ideally, every term. And so depending on the term and the server number, the peer number, 0, 1, 2 here, it picks a different timeout, but the timeouts are all kept relatively far from each other. That's an interesting idea that kind of avoids randomization. Pick a random permutation and then assign timeouts like that in fairly consistently spaced apart. I don't know. Maybe it's unnecessary, probably an over-optimization. Because fine, 1 became candidate, and then 2 became candidate, and then 1 became candidate, but then 1 finally became leader. Is it possible to, because, the votes all came through, but is it, possible for 1 to optimize that code slightly so that, in the case of the voting system, which is still bundled in the candidate section, it awaits votes, all the votes came through, and then it runs init leader. But it doesn't set itself to be a leader until init leader is entered, and so that the Go scheduler probably delays that. So maybe init leader should be set before the leader call, i.e. here. But that would make the code a lot more difficult to read. I have a really strong assertion in the code right now. That is, phases are only set at the beginning of the relevant init functions, initializers, and while it is true that those functions may get put off, delayed by the scheduler, they still, if they do happen to be entered, they do at least definitely run. And that's how it goes. And maybe what I should do is reuse Go routines in order to prevent that from happening. In that case, I would not be able to use defers. I would have to, lock and unlock manually. But then reuse the Go routine. It would be kind of hackish to manually assign the phase to be leader here. instead of waiting for it to happen within init leader. But running this on the same thread would immediately push it into being a leader. Else it just runs a new thread, but I don't know. I will think about that if it turns into more of a problem. Yeah, it is a bit dodgy that basically a split vote type situation happened so many times. Even though the votes were all counted on time, it didn't get to become a leader because this thing triggered a new vote instead, and then that pushed it to being a follower. Which obviously then means even though it's init leader is started, because it's now a follower, init leader does the candidate check and fails that, and so returns. Yeah, it's unfortunate that that's how it went, but once it finally becomes a leader, like why does it then become a follower? Maybe I need to break it down slightly and conceptualize why things are becoming leaders and followers. Specify a reason for every phase change. And that would mean that phase changes should really be done at the ends of functions, which would make it difficult to read, like I said, but it would make it clearer why a phase change occurred if I debug it by, yeah, okay. Sorry, let's just flick through the rest of this. 2 becomes a candidate again. It gets voted for, append entries are happening, but that's just a network failure. 1 times out becomes candidate, which makes 2 a follower. 2 becomes a candidate. Do you see how in this code at no point is anything other than 0 sending out append entries? So none of them actually properly become followers. Sorry, none of them properly become leaders ever. And eventually what happens is like 0 starts successfully communicating and it sends messages to itself somehow. I don't know why that keeps happening. With append entries there is a bug of sending messages to yourself, which I need to check. Maybe I should just block that from happening here, but no, I'm not gonna. I'm just gonna. The point where that's happened is in the heartbeat. If ID is not myself, send it. But somehow it's sending from 0 to itself. But RFMe is something that should never change. So that's a weird bug as well. No, the code is just hella messy, to be honest. Hella screwy, and it's passed the test, but that's just because 0 came back to life. Oh yeah, but 2 became a leader. Because once 0 finally managed to communicate with 2, the term was so out of date that the RPC term sync pushed 2 into being a lead, pushed 0 into being a follower. No, 2 became a leader because it. Why did 2 become a leader? Look at this. It requested votes and it didn't receive votes at all. It just became a leader somehow. Wow. Complicated. Yeah, no joke, this shit is difficult. But either way, somehow 2 became the leader. Somehow 2 became the leader. And 0 and 1 both became followers because But then why is 0 still sending append entries? I think there's a bug in my introspection. Yeah, there's a bug in my print statement. Here I think it just always says 0 or something. My append entries print statement is wrecked, I think. Sorry, that should be in send append entries. Yeah, the print statement within that is just sort of chatting shit, to be honest. args.leaderID. Let me just quickly check what that is. Leader ID is it should just correspond to the thing that sent the message. Sender. Because yeah, it's in the send append entries phase. This should be myself. This should be what I'm sending to. So args.leaderID is the sender. Surely. Is it? Let me check that by going into the thing that calls send append entries, which is the heartbeat. Whatever is running that. Oh, wow, I'm not assigning append entries args correctly. That's why it always says that 0 is sending, even though it's not. God, again, sorry, I just pressed Z by accident or something. Yep, yeah, I need to specify the term and the leader ID within my send. Sorry, I cannot send absolutely empty append entries arguments. That's absolutely not on. I don't know why I thought I could get away with that. My bad, let me just fix that. So the thing that sends it out, so init candidate sends out you know, things along these lines basically into the RPC. So I'm just gonna paste that into the heartbeat function. Args is append entries args. Right, the term is my current term. Oh yeah, the current term has to go out in the damn heartbeat, doesn't it? So I need to lock while I'm sending. While I'm sending out heartbeats, I have to lock. Because my term has to be consistent and turn up in all of the heartbeats. Yeah, because I was getting a default value of 0, but okay. That's why it always seems like 0 is sending heartbeats, but it's actually not. So instead, candidate ID does not exist. Instead it's called leader ID. It's highlighted, yeah, the wrong thing there. It should highlight the key, not the value, but anyway. Leader ID is myself. Term is my current term. So yeah, 100% have to send the correct arguments in, and the arguments that are coming out are handled by the replier, which is append entries. Yep. Which actually does reply with the correct term, and so a synchronization can happen. Okay, understood. So yeah, it should be working. I think my printing was dodge there. But yeah, it should be working. So I'm gonna just print it out. Go test run. Let's just run both of them and print it out. Oh god, this is, yeah, it's messy, isn't it? About as messy as can be. I'm trying my best to not speak too confusingly. Unfortunately, definitely failing that, but just trying to. Lots of things going wrong at the same time. Trying to just explain my way through all of that. So again, as you can see, we have a pass, so we have finished it. But I just want to make sure that like I can reason through the program code and understand it, so it actually has passed, because that will make it easier to pass future tests. If I can go through this and understand it through my concept of how Raft should work. So yeah, you see append entries is now actually talking about the correct thing. So let's yeah, do a quick reason through both of the tests. So first of all, 2 times out becomes candidate, gets its votes, becomes leader. Then it's constantly sending append entries and receiving a confirmation, and the others are constantly resetting, right? So that works correctly. Append entries 2 is always setting off and working, okay. And the resets are also always happening, so that's a pass. After network failure, there's a problem here is that when running one test after the other, it doesn't fully exit the program. So you can see append entries are still happening. Or maybe these are just from the other instance of the program, and so they should just be ignored. But yeah, there should really be a pause of like 1 second between running tests so that this kind of stuff doesn't happen. It's a bit messy. I'm gonna think about fixing that, but for the time being, yeah, I believe that this actually corresponds to the previous test. There should just be a break, like a time pause between tests in order to stop this kind of thing from happening. Lost RPCs as well. You can see there are no replies coming through these. Maybe just a quick thing. There's a kill thing here. The tester calls kill when a Raft instance won't be needed again. You're not required to do anything, but it might be convenient to, for example, turn off debug output from this instance. Right, I see what it's saying. So, you know, getting rid of this shit for that particular instance. I need a way of turning the debug output on and off, or else, yeah, it's leaking. It's annoying that it didn't explicitly specify that leaking could be a problem, like this kind of thing, that this from the previous one jumps here. But that's probably what it means by might be convenient to turn off debug output. I am, as a result of that, going to try to sort that out. I can do that just by turning p into a trivial function. Okay, so what I mean by that is in the kill section, I just assign p, the global variable, to be a trivial function that does nothing. I mean, it's a trivial function, but you have to like specify the correct signature because strongly types and shit. This is the correct signature. It's just some boilerplate. Have I spelled it wrong? Oh no, I have to specify the exits as well. So it has to be int and error. And then return. my trivial function is going to be return literally just want to return the trivial values. I can do that by doing this. Oh no, I can't because they're not named. Fine, I will name them. This is valid syntax. It's a bit unconventional, but in Go you can specify in the signature what the return variable is going to be, and then yeah, just return. Even if you just return here, it will return the default values of these variables, so that's fine. Fucking linter again. Cool. That should fix the output problem. So let's just run the test again. Interesting, this time it failed. Test re-election doesn't... Yeah, test re-election didn't log anything, so I have to actually... I have to reassign to P every time I start the damn tester, which is just an absolute nuisance. But yeah, debugging is never easy. Testing and getting test routines to work well with your original code is always a bit of a nightmare. Certainly in Node, JavaScript, I never really got it working. Unit testing and that kind of thing. I did get some limited unit testing going for my latest project. Some of the most important stuff I unit tested, but yeah, as a general point, it was just very difficult to organize. All sorts of random errors acts. Can't even be bothered to talk about them. Alright. So you can see it's not actually passing the test. I got a fail there. No. Man, I just saw 3 copies of the same kid walk by. That is weird. That is so dodge. Yeah, see, this achieved absolutely nothing. I need the shit output is still happening. Why not just like close down the entire process? Honestly, I could not tell you what's wrong with it, like how to get that organized. The debugger and that, I'm just gonna have to worry about that some other time. I cannot be bothered to deal with that, but yeah. So just try to ignore this. One times out becomes candidate requests vote. So okay, so like I said, I'm looking into the second test and seeing if it is working approximately as intended. So they all start as followers. This is from the previous test, I think. One times out becomes candidate requests votes. Becomes leader, but somehow the print statement doesn't seem to register that the votes came back. So I think I have the print statements in the wrong place. Request votes. Yeah, as in the vote grant should be happening. I should write that down before the vote is sent. Well, surely the handler must exit in order for the RPC to. I don't know. Sorry, I just do not know why that's not commenting that the vote succeeded. Okay, anyway, so 2 is appending entries. 1 times out candidate and then becomes leader. Starts appending entries, but 2 does as well. And then 0 times out becomes candidate, request to vote, becomes leader itself. So all of them, this is total chaos. All of them are appending entries. None of them is switching to follower, despite the fact that it's receiving append entries. Receipt of append entries should immediately switch something to be a follower. I think that's a bug that I'll just try to quickly fix. You know, so in the event that the terms mismatch, it just becomes a follower. Payloads this, but the point is it received an append entries. Oh, okay, I think that's a fairly key piece of code. You know, when something receives append entries, it needs to become a follower. Does it say that anywhere? No, it doesn't, but it just fits my understanding of how Raft works, so I'm going to put it in anyway. Come on. It's going to turn itself into a follower, regardless of what happens. So I don't need this line of code, although conceptually it does also fit there. It's another thing that could cause it to become a follower. So yeah, I'm forcing them to become followers now if they receive. If anything receives an append entry, heartbeat, I'm going to force it to become a follower. And that's how it's going to go. So I'm going to do the manual tests. Writing it as re-election just because I don't want the other test to interfere with the output. I don't know how I'm going to fix that, honestly. I haven't figured it out yet. Does this now succeed? No, it doesn't. It started failing again. So look, 1 becomes candidates, requests votes, it becomes a leader, and it appends entries, which is resetting. Yeah, it's resetting these, but these are already followers, so they don't become followers again. So 1 is the leader, and it's going to get disconnected here. 2 times out becomes candidate, gets a vote. 0 times out and becomes a candidate. In the future term, gets votes, becomes follower. Append entries is still sending shit. As in number 1 is still sending shit out, but no one's detecting it. 2 times out, because 0 is not sending stuff either, becomes a candidate, requests votes, doesn't become leader yet. 0 is now follower, 0 times out again, candidate. 2 is now follower, 2 timed out is a candidate, 0 is now follower, but nothing is becoming leader. How much more time am I willing to spend on this? I think a fairly major code restructure is going to be necessary in order to get all of the things to change their states as soon as possible without being at the head of a new coroutine, a Go routine, which is what I've been doing so far. Every change between follower, leader, and candidate happens at the beginning of a Go routine, but I think that's causing problems. What I need is it to happen earlier than that, and it also needs to specify a reason why the state change happened and then run the initialization function. Only when a state change happens do you run an initialization function. There are different ways of thinking about that, different ways of implementing. I think I need a break to get it straight in my head, to be honest, how to organize that. So I'm gonna, even though I haven't finished debugging, I'm gonna take a break for that reason. Don't know how a leader did manage to get elected here. That's just odd. Okay, listen. One thing that's going to help me tremendously, and so I'm going to do it now, is to split everything up into separate files, right? So this is something I've been meaning to do for a while, just to make the code easier to browse. Right, it'll make me a lot faster, and it'll make it easier for me to find things. And so I'm hoping I know how to do that. I'm just going to test it now. I'm going to bravely jump in and hope that I know how to do that. And then I'm going to test it again to see if it vaguely seems to be working, and yeah, hope. Let's hope. Okay, let's do it. So splitting things up, that's what's going on. I'm going to just make bare new files. So many new files. So we're going to have RPC request vote to handle all of the request vote stuff. We're going to have RPC append entries likewise. So the two structs and two functions that correspond, let me just tip down, that corresponds to each of those. So for both of those RPCs, they have two functions, the sender and receiver, and two structs, send in arguments and receive arguments. Those two things, reply arguments, if you like, for the receive arguments. Those four things I'm going to bundle up into files corresponding to that RPC. Here they are. Just going to do that now. So yeah, as my first experiment in splitting things up, I'm going to try to just do that. So this is how I think it should be done, okay? Sorry, just moving the microphone. This is how, volumes, okay, yeah, fine. Cool, this is how I think it should be done. So, the setting position is just hilarious, isn't it? Actually, there seems to be a bit of camera lag. Thankfully not, no camera lag, okay. Sorry, let's get back to it. This is how I think splitting should be done. Package Raft goes on the top of everything that I want to be part of the same thing. Yeah, the control button is still struggling to work on this laptop for some reason. Okay. All of the imports all of the imports I'm also just going to copy straight over. If they get deleted later on and I can just reintroduce them, that's fine. P is exported, so that's fine. Potentially the things that are shared have to be capitalized in order to be shared across the package. Just something to bear in mind. Let's find out. So request vote RPC is the first thing that's getting copied out. God, yeah, the send request vote paragraph is just so long. Scroll up. Damn you. Very bravely, just copying all of the code across. It says it's redeclared because I haven't saved this document. Okay. And let me just do the same for append entries, and then I'll save all the documents and check for errors. Okay. Yeah, no problems. It seems to be detecting the locations of everything. You see these persistence functions? This one's typed in small text. Persister.go is itself another thing. So maybe I'll leave the persistence code in and just put it somewhere at the bottom or something, I'm not sure. Well, okay, I've cut out the RPC code, so that's already simplified it substantially, but the actual, things that do things code should also be moved into a different file, I think. Init candidate, init follower, heartbeats, init leader. And yeah, okay, we have make and kill and start. Well, I've removed 50 lines, well, less because of the duplicated imports, like 45 lines here and 85 here, still pretty good. So yeah, that seems to work. Let's just do a test. Yeah, let's just do 2A and cut it. Initial election. Yeah, no, it seems to be working absolutely fine. Look at all these things, just the pending entries, and so many things are pending entries, yet none of them seem to claim to be leader. That's really buggy code on my part. I'm sorry. Things will have to be split up a lot better, and yeah, work will have to be done to reorganize everything. Yep, get state and Raft and this stuff is just the basic stuff. Interface stuff, persister and that, and yeah, let's put the custom code into a different folder. Definitely. Whether or not it's exported doesn't matter, so I'm completely happy to capitalize this stuff if need be. So yeah, instead of raft.go, let's call it something like well, I want a file name that describes the fact that I'm going to just dump in literally all of these system, the functions that govern the flow of the entire program, like phase changes and actually doing stuff. All that stuff is going to be dumped into a separate file. And I'm going to leave the interface stuff in raft.go. So, what's a good way of calling it? It's like the lower level to the interface stuff, which is in Raft.go. Maybe it should just be called Raft itself, and this should be called like interface. No, I'm going to call it something like Raft. Raft flow. Yeah, I'm not going to think too hard. I'm just going to rename that if I need to. I didn't need to import anything here apparently. Well, I mean, you say that. Yeah, because the imports are all contained in other things, and so not needed. Yeah, I didn't need to import anything. Curious, but there it is. Yeah. Nonetheless, I can copy in all of the imports, and they will just get deleted out if they're not necessary. Once I've split the code up, so it'll show me exactly what I'm importing in each file, which libraries I'm using. That's what I mean. So watch this, save. See, it's just stuck me to those things. And if I scroll to the top of Raft, I can also just see the dependencies that I don't need just disappear just like that. No problems. Yep, it seems that even though it's not exported, not available to things that use Raft, nonetheless, as in, so the names that start with function names and every declaration that starts with a small letter is not exported, but it's still accessible to everything within the package itself. So the Raft package declaration specifies that everything is accessible. This is accessible in the other file, but anything that uses the Raft package as interfacing with it, like the state machine service, the key value service that we're going to implement in project 3, that would not be able to see this. It would only be able to see the capitalized stuff. So that's a convention in Go. Capitalization means accessible externally. Okay. Yeah, this is still working fine, as in the actual code splits are absolutely okay. Yeah, so now, Raft, the original Raft.go does not actually contain anything too important. Just code for initialization, where do you begin, the follower loop, that kind of stuff. Yeah. The kill code, I still don't know how to run that, and whatever start does. Oh yeah, starts the actual client interface. Cool. Yeah, basically. So this is now 200 lines, this is now 100, and these two are like, one's 50 and the others are 100, I think. That one's 50, this one's, 90 because of all the comments. That's it. Things are not working. We're going to have to go into another debug session. I'm going to just stop now and get lunch or whatever. Yeah, the struggle is real. What I am going to do... Yeah, I will, what shall I do? I'm just going to, I'm going to stop streaming now. I'm going to stop this sesh and move on to the next sesh. So I'm going to do all the stuff associated with that. So git push. I'm going to upload this and it's going to end up on GitHub as well imminently. I'm just going to commit it. So yeah, I don't need the out file to actually remain. I can just delete it each time. But yeah, basically, see, I've split it up into 4 files, and I've done all my source code edits. So I have finished session 5, I believe. Still debugging 2A. Okay? Commit all that out. Yeah, and that's it. Close. Okay, so guys, next session is going to be when I said it was going to be, actually. So I brought it slightly forward from the last one, the usual timings. So I'm gonna just straight up do a session 12 p.m. tomorrow. Tomorrow being Tuesday. It's going to be a very short session because the only thing I intend to do is finish reorganizing my code and the debugging process for Project 2A. What I've been doing today. I just intend to finish that and then leave it. So, as you saw, the tests did pass occasionally. For the second test, the first test seems to be passing reliably, but the second test for question 2A was passing for a bit, but then failing, and it didn't seem to be working correctly anyway, even when passing. So I'm going to reason through the program, make sure it looks like it's working correctly, and fix it up. The big change I'm going to make in order to make debugging easier is every phase transition is going to be called immediately within the piece of code that. So every time a phase transition is triggered, that's going to happen immediately. As in, what I've been doing so far is I've been doing phase transitions at the beginning of whatever that piece of code is going to be doing next. So like, I want to become a leader, for example. Well, then what I do is call go initialize leader, and initialize leader changes the phase. So that seems to be, I feel bad about that. It feels like, because the init leader is not immediately going to get called, we're still using separate go routines for everything, pretty much. That phase transition may get delayed, and that could cause all sorts of problems because based on things still behaving like a leader, different coroutines not knowing that the leader transition should have happened immediately. So instead I am going to do phase transitions, phase being leader, follower, candidate. I'm going to do phase transitions at the end of whatever code. The code that actually triggered the phase transition is going to change the phase, and then it's going to trigger a separate go routine before exiting. And that go routine is going to then actually enact the phase, the stuff that it's supposed to be doing in the new phase. I think that's a more logical subdivision, and it also allows me to introspect a bit harder because every phase transition can be labeled as a debug. This is where the phase transition happened, much like what I've been doing so far, except because the phase transition happens in the context of the function that triggered it, I can also write down the information of what triggered the phase transition. So should we just list some off the top of our heads? Like, a thing can become a follower for like 10 different reasons. Leader only ever happens if it won an election, so it's going to be like the won an election event triggered the leader becoming a leader. The thing becoming a candidate could be triggered by split vote, or it could be triggered by election timeout. Those two things. And likewise, becoming a follower could be triggered by initializing the entire program. The whole program starting makes everything a follower. It could be triggered by a term, an RPC term handshake violation, so the term being out of date triggers something to become a follower. It could also be triggered by receiving an append entry. That could trigger something becoming a follower. Those 3 things in principle, probably a few others. No need to list them all. As I go through the code, it will be clear why I am calling a transition. And so I'm just going to make a function that reports the transition why it happened, does the phase change. I might even make a separate routine that does that, so it prints the phase change, does the phase change, and then triggers the initializer for the next phase in a separate Go routine. And that will just make it easier to debug. I don't know why it's broken now, but it will become clearer once that happens, okay? So that is what I am doing next sesh. Tuesday, straight into Tuesday the 12th of June at 12 p.m. Do that, hopefully finish debugging to the point where not only do the tests pass, but I actually can reason through what's going on fairly reliably. It seems to be working fine. You know, it's performant. The code is not like getting stuck, it's not doing weird shit. Everything seems to be okay. Okay? That's the point that I aim to get to next sesh. And yeah, then I will talk about truck outside. Then I will talk about the future of the Raft project. It's definitely going a lot slower than I was hoping. It's probably a dumpster truck or something. It's definitely going a lot slower than I was hoping, but once that's done, I'll be fairly happy that 2A is mostly done. Hardest part is probably going to be the first part. So I'll be happy that I will finish everything else off, even though I haven't even touched the data phase yet. But because it's difficult and long, what I will say is, and I don't have that much time by the 14th when I'm finishing streaming, well, when I'm going to get really busy with other things. So I'm going to reassess my plan and just take it from there. So I'm just going to discuss all that tomorrow at the end of the stream once we're done debugging 2A, okay? So yeah, 2A, still not debugged, but we're getting there. And I'm going to fix everything up. I have a plan for how to make everything much more debuggable. Just going to roll through with that plan to it. Sesh 6, I think. Next sesh, 12th of June, 12 p.m. Forever.